Here viewers, today I'm going to show the configurable converter which is connected with the DAB converter. Okay, so at this part we have connected the battery at the output side to charge this battery. Okay, so basically DAB converter in the charging mode. Okay, so we have connected the same configuration and same connection at explained in the part 1. Okay, so now in this part we will see the performance of the DAB converter with charging of this 48 volt 15 ampere battery. Okay, so basically we have connected the controller, we have connected the DAB converter, and the output side by using this DC MCB we have connected this battery. Okay, so and this battery is with the BMS system, so we have connected this RS485 cable with our laptop. Okay, so basically in this part we will see the performance of the DAB converter in the charging mode. Okay, so first of all we have given the three different code. First code is for the just check the performance of DAB converter with the R load. Okay, second code we have given the for the battery charging, and the third code we have given with the battery discharging. Okay, so now first of all you can just we have provided the hex file. Okay, so first of all you can just open the cube STM cube programmer. Okay, then you can connect your controller with your laptop. Okay, so first of all you can just see the DC is 0, then after you can just connect this with the laptop. Okay, controller with the laptop. Okay, now you can just go to the so now you can just go to the plus, open file. Okay, and where you have put your hex file, you can just find the charging hex. Okay, charge DAB converter 40 kilohertz open loop closed loop charging dot hex. Okay, just you can open it. Okay, then you can just press the download. Okay, once the download is totally completed, then press OK. Okay, then you can just press the disconnect button. Okay, so you can just hear it is successfully disconnected and the file is download completed. So two message we can compulsorily read it, then you can minimize it, and all first once you can disconnect this cable, and you can just press once the code controller, so you can just see the battery charging code is there. Okay, so in this battery charging code now you can just see okay, now this is the code changing process. Okay, after that we have given this battery with the BMS system. So go to the we have provided with this setup we have provided the one battery. Okay, so the battery BMS software are there, Pixel e-mobility software like this. Okay, so what you can do is just go to the device manager, or just go just open it. Okay, so for the use of this software you need the .NET framework. Okay, in your laptop just go to the COM port. Okay, and whatever available COM port we have seen, you can just connect it. Okay, and you can just press the connect button. So all the information of the battery we can get in this software. Okay, all the cell voltage we have data. Okay, so it is a millivolt. Okay, data, and here the full capacity of battery, the remaining capacity means 50% SOCs are there, so the remaining capacity we have this. Okay, and here you can see the battery voltage, battery current, charging mode means the CC or the CV charging are there. This is the some protections it is given here. Okay, and if you need to log the data, then you can just first select the path, any path you can select it. Okay, then you can just see what data you need. Okay, charging data or discharging data. So this time we have mode with the charging, so we have go with the charging, and we have once it is start, then we have placed the start data start, so it is logged all the data. Okay, then here we have many protections are there. Okay, so at the time of charging this battery, you can just go to this MOS control section, and you can just deactivate this discharge MOS. Okay, and you can press the set button. So once you have set, basically the initially it is like this. Okay, both MOS is there, so all the MOS status is green. Okay, so basically what you need to do, you can just disconnect your discharging MOS, and you can just press the set button. So system software lock error are there, but it is not error, it is the warning. Okay, so only the discharging we have supported with this battery now. Okay, so we have just charged the battery, it is not effect in the discharging. Okay, okay, now this software we have, by using this software we have get the data of this battery. Okay, so we have connected basically the DAB converter. Okay, configurable converter on the DAB mode. Okay, now we have changed the code, we have get the battery data, we have all the connection we have made. Now we have turn on the grid, and we have apply the input voltage first. Okay, so input voltage we have given is the 400 volt DC. Okay, so 400 volt we have given here. Then you can just turn on this MCB. Okay, so turn on the MCB first. Okay, and you can just see the phase shift, you can apply as a 0 phase shift we have applied here, and here you can just see the current is 00, voltage is 49. Okay, now we have turn on the system. Okay, so turn on. So basically once you have turn on, the battery voltage is 50 volt, and you can just see the current is like this. Okay, so gate pulses and the current, it is triangular like that. Okay, and at this time the current is, battery current is 7.3 ampere. Okay, 50 volt is there. Okay, now what we can do is, we can just you can just see it is in the CV mode. Okay, now we can increase the phase shift and see the performance. Okay, so when I am increasing the phase shift, you can just see the current is now increasing. Okay, so maximum current we have limit at the battery charging is 10 ampere, so we have given the 10 ampere current. Okay, so now the battery is in the charging mode. Okay, so the battery charging voltage is for 53 volt. Okay, so battery SOC at this time is battery SOC is 51%. So first of all it will try to maintain at CV, and 53 volt here we have maintained at the 10 ampere current. After the reaching of CV, okay, 53 volt, it is in the CC mode. Okay, so now you can just see the wave shape, current shape. Okay, now you can see the current wave shape. Okay, and the phase shift. Okay, then here. Okay, now this is in the open loop mode, performance of the battery charging performance in the open loop mode. Now basically this is only to verify the system is working or not, but you can just turn it is working only for the few minutes. Okay, then you can turn off then you can just go to the closed loop. For the charging of this battery, or you can demo the DAP converter with the battery charging, then you can just go to the closed loop. Mandatorily go to the closed loop, and you can work with this closed loop, and you can charge your battery in the closed loop mode. So it is automatically toggle in the CV and CC mode. Okay, so now the voltage is 50 volt, current is 0. Okay, so battery charging voltage is 53. So here we have set the 53 volt. Okay, 53 volt here, but first of all we will see the CC mode, then CV mode. Okay, so we have applied 400 volt here. Okay, some battery voltage is here. Okay, so now turn on the system. Okay, so I am turning on the system, and you can just see 400 volt input at the 50 volt output. So here it is maintained the 50 volt. Okay, here you can just see the 50 volt is maintained here. Okay, the input current, power and phase shift, like this it is maintaining here. And the current is, you can just see, current is gradually decreasing. Okay, means it is in the CV mode. Okay, means it is made, if it is maintained the 50 volt, then the current is decreased. Okay, sorry, if it is maintained in the CC mode, maintaining the voltage, and it is going with the CC mode, then it is matched with the 50 volt to 50 volt. Here same 50 volt to 50 volt, and the current is decreasing. Okay, so now what we can do is, we can just set the reference voltage at the charging voltage. Okay, so here the charging voltage is 53 volt, so we can increase the charging reference voltage to 53, and it is going to, just you can see the performance. The current is increasing, and the voltage is try to maintain at 53 volt. Okay, but it is taking some time to maintain the 53 volt. Okay, so here the voltage is 51.3 volt. So it is now, the battery is in the CV mode. Okay, first we have seen the CC mode, but now it is the CV mode. Once it is getting the 53 volt charging volt properly charged, and it is getting the 53 volt, then it is going in the CC mode. Okay, so now you can just see the phase shift is 5%. Okay, phase shift is 5%. Power is maintained the 500 watt. Okay, and reference voltage is 53 volt. Okay, and the output current is 10 ampere. So here we have limit the current, charging current is the 10 ampere, so it is maintained at the 10 ampere. Okay, and also you can see here it is charging the battery. Okay, and also you can see the phase shift. Okay, some phase shift is applied here, so the current shaping like this. Okay, with respect to gate pulse of first bridge, first switch. Okay, so now this battery is charging perfectly with the 400 volt to 53 volt at 10 ampere current. Okay, so the battery SOC is now 53 volt. At some time we will see the SOC. Okay, so now after 10 minutes I have retaken this video. So you can just see the battery is charging in the 10 minutes. The battery is charging with the 2%. So before 10 minutes it is 53% SOC, and now it is the 55% SOC. So likewise the DAP converter is working with the CCCV mode. okay, and it is perfectly transfer the power, okay, and it is charge the battery properly. Okay, thank you. In the next video we will see the discharging of the battery. Thank you.